So, beautiful, thank you. Can we just get a quick hand for our AV team? Thank you. This is beautiful. Yeah, I remember being here last year and we just had the room completely dark, which apparently sucked when you were at home, but at least the slides here were legible. And there we go. If you're watching this from home, I apologize for the screen flashes you're experiencing. It's definitely not nice, but good morning, good afternoon, depending on how well daylight savings treated you. Super excited to show you what kind of crazy stuff we built in the past few months. And specifically, we want to talk about, well, controlling robots in user-hostile and dark environments.
I think you mean controlling them the same way as NASA does.
Yeah, of course. I mean, this is JPL Town. You see the ads everywhere. You know, build robots, not meme apps. I love that. If you have kids that like robots, definitely let them build stuff.
So, hello everyone, my name is Adrian. I'm a solutions architect at HashiCorp, and before that, I used to be my true passion, a site reliability engineer.
That is nobody's true passion. Nobody wants to get paged at 3 in the morning.
It's fun. I promise.
It's a lie. Well, hello everyone. My name is Kareem Satirli. I'm a senior developer advocate at HashiCorp, where I get to tell people about best practices and how to build them, implement them, but I don't get paged, which is a part I love about my job. Before joining HashiCorp, I worked on industrial IoT for the Amsterdam airport, which sounds super glamorous, but all we looked at was sewage pumps, which is a less fun part of IoT. So last year we presented something here, a concept called batch computing. The AE is on purpose because it's a badge, but it's also an edge compute device. We had a Raspberry Pi Zero in there. Really badly supported Python libraries, incredibly bad code. Not ours, but the code we started from. And I think we learned some important lessons. There is a distinction between the smell of a molten MOSFET and one that's currently melting. If you understand that joke, I'm so sorry, because you probably also have the puncture holes on your fingers. And so we thought, you know what, this was an absolutely horrible experience, so we're going to go and make it more horrible. Instead of going towards languages that embrace you, that welcome you with warm, welcoming communities, we figured, you know what, we'll go a little bit back. We'll go more towards embedded computing, where Copilot gives you stuff and then just laughs at you because, like, what are you trying here? Like, I don't have a data set that can help with the question you have, but the code looks good. So I want to talk a little bit about the goals of what we're building and what we're planning on building. At the base, we want to have something really simple, right? Remotely control a device. We do this all the time. I mean, I'm currently remote controlling my slides here. Well, we're kind of messing with the camera feed by switching the light on and off. You have a device, you give it instructions, it does what it's intended to do, it's great. Love it when that works. Doesn't always, right? If you've written enough code, no matter what kind, you know that the code sometimes does its own thing, and things get harder. And here's the really hard part. We want all of our instructions to be followed all the time. If you do work with ChatGPT or any other prompting system, you know this, you specifically say, follow my instructions, give me all the goods, tell me what day it is today because you want to have the most accurate data set. When you work with robots, 3 laws of robotics, very important. But even so, the machine might not always do what it needs to do. I know this is starting to get a little bit theoretical, so let's make this more practical. Ghost in a machine is a real thing. Sometimes, despite all the best planning, things don't go as planned. Just like what happened 2 days ago, Friday. Sorry, Sunday. Man, time flies. With the Athena lunar lander. It got the lunar part right. It made it there. Struggled somewhat with the landing part. To give you an idea, these are the legs. when they're pointed upward, is not optimal. Mission has since been concluded, which as an engineer, I feel really bad for these people because you plan this for months, for weeks, for years. And then because one thing goes wrong at the end, this is all you get. It's a pretty cool wallpaper though. It's a good reminder of things that can go wrong that you have zero control over. Not as cool as the story of something else with metric versus imperial. We'll get into that later, but definitely a lot of fun. So Adrian and I work at HashiCorp. One of the tools we make is Terraform. And if you've used early Terraform, you definitely know that you would tell it, give me a web server, give me a database server. Everything would look good. And on the first run, well, computers don't always do what you tell them to do. So maybe on the second run, it worked out. Well, so let's update our goal. Let's make it more fun. We're going to build a robot, do something fun with it, do something potentially useful with it. I mean, anytime you're learning, it's useful. So that's our primary goal. And what we really want to do is start somewhere, empty canvas.
So as engineers, we really like greenfield projects where we start from scratch, we do whatever we want, there are no constraints, no limitations, nobody has restricted us on the language, architectural choices, etc., etc. But they're not always the best approach, because even when doing this for fun, like we are, there are timelines, like a conference, and timelines mean deadlines, so we can't just spend years working on this and developing everything from scratch in Rust, even though we might like to. So, what's the alternative?
Brownfield.
Yeah, sometimes a good alternative, but there is also another one which we chose, which was better for us, probably, hopefully, commercial off the shelf. So starting with something which already exists, which you can acquire from a hopefully reputable vendor, which saves you time, prevents you from reinventing the wheel, and everybody does it. Like the US Navy does it when they buy ships. Sometimes they try to, when they're forced to. NASA does it, like they've been using an IBM-designed single-board computer from IBM, which I already said, for the past 2 decades, and of course the ISS uses Lenovo ThinkPads, which you've probably seen on videos. So yeah, that's what we decided as well. We bought some hardware off the shelf, which looks like this.
Before we dive into our hardware, quick note on that single board computer. The RAD 7050 is indeed, as the name implies, very rad. 370 grand for 110 megahertz CPU, but you can absolutely overclock it up to 200, get all the speed out there. And we're all laughing at this, right? Because, yeah, the ESP32s that we use for our robots have 240 megahertz. Yet we're talking about hardware that's been in space for 20 plus years, on plenty of missions, still works. I mean, if that's not the reliability we're aspiring, then what the hell are we doing? So last year we started, that was one too many. Last year we started building this project with our first rover. We call it Pathfinders, obviously an homage to the actual Pathfinders that were sent up at one point. Started out with a pretty cute system, 4 wheels, very nice. Some younger members of my household decided to stick rubber ducks on it to make them more personal. I like their identity to be based on the MAC address, but you know, we do what we can. But ultimately realized 4-wheel drive does not really work, and there's a reason why all the rovers have 6 wheels. So that's where we went. Of course, the lowest bidder won. So we have 6 wheels, but only 4 wheels are actually powered. But we still get a 25% bigger footprint. This is a render of the actual device that we have. So you'll note a couple of rails on top. Well, guess not in this render. Rails on top for cameras, robotic arms, whatever we want to put on there. Given, of course, it's less than, was it the 5 pounds, or 2.5 kilos if you prefer metric. So biggest thing, really, for all of them, we base them around ESP32 because that gives us, access to a lot of code that we don't have to write ourselves. Always beautiful. The whole Arduino ecosystem is really good at giving you access to all the stuff that you don't want to figure out by going through hundreds and hundreds of spec sheets. Bluetooth, Wi-Fi, we're not using Bluetooth, not very reliable for what we want, and it's easier to pre-seed Wi-Fi stations than doing constant Bluetooth handovers. The real beauty here is access to host computers that you can install. In our case, Raspberry Pis, Jetson Nano, Jetson Orans. So you can do a little bit of AI processing at the edge, provided you can give enough power to those devices. The more processing you do, usually the heavier your hardware gets, which has more strain on the system. And we're only powering this with 3 of the standard industrial batteries that you come across everywhere, that TSA is absolutely a huge fan of when you bring many of them in your suitcase. Seriously though, don't ever do that. These are hand carry-on only. And let them know, because they show up on the system. So, GPIO, standard interface, right? All the good stuff. Ability to power Raspberry Pi directly, which is very nice. The Jetsons, a little bit harder because they require a little bit more power. Support for LiDAR, like the actual board in there has a connection interface that allows us to take LiDAR data and process it. And of course, plenty of expansion ports if we want to drive a gimbal or an additional camera or whatever else we need. And like I mentioned, 4-wheel drive on 6 wheels. When we got this thing, beautiful packaging, right? Not Apple inspired, but definitely higher end for IoT devices. We were like, well, this looks great. Let's unpack it. You look at the box and the demo code that comes with a little QR code, like please scan this link, it gets redirected 6 times, and you end up there. Yeah, that code, we'll talk about that part later. The care that went into designing the shell was definitely higher than the care that went into designing the code. And yeah, deadlines. So hardware, easy part, right? I mean, at this point, 3D print whatever you need, get to the software part. Written in C++, which if you grew up in the PHP era like me, you've never touched. Steep learning curve. Code had some imperfections, I want to say. Most comments were the prompts that were used for ChatGPT, written in Mandarin, and they were also the only comments in the code. But luckily, throw those prompts into a translation tool to figure out what the prompt said, figure out what the original intent was. It almost feels like you're bonding with that engineer. It's beautiful. Arduino ecosystem helped us greatly in terms of helping understand, why is the wheel moving the way it is moving, or why is it not moving? It's probably the more realistic outcome. And you learn fun things, like normally I would think a wheel, has 2 states, a motor has 2 states, either you spin or you don't, or you move, doesn't have to be spinning. In our case, the software interface was using an LED library, so we were using pulse width modulation, and basically pulsing the wheel to keep going, which when you have a lot of logging in your code, makes it very hard to understand what's going on. So, of course, like any true engineer, we took all that code, refactored it, made it better, built a Terraform provider around it, made the API actually more fun to use, and figured, infrastructure as code, Terraform, yes, here, but why not do something that we could use anywhere? And how do you go about building the API? So, kind of jumped into that a little bit. And then comes the fun part. Once you have your first goal is completed, right? The thing moves when you tell it to, the thing stops when you tell it to. Life gets really good. You feel great, especially because you wrote code that never worked in the first place. Well, what can we do? Well, obviously, we add cameras. In our case, we're currently experimenting with a system of 4 cameras, which gives us around 300-degree vision, because of the design of the device, we don't get full 360 and the placement of the cameras, but still enough for us to see what's happening. And then, of course, we like edge orchestration. Not everything has to run on the ESP32s. So anytime we can go to a more well-understood system, like a Raspberry Pi, anything that we want, or the Jetsons, we can fall back to Nomad, which gives us orchestration at the edge. And when you think about it, remotely controlling a robot is fun, right? I mean, from early age on, like age 3, 4, whenever you get your first remote-controlled toy, car, whatever, even the ones, our daughter is 2, she's got one of those toys that interacts with her without a remote control, simply by gestures. Very cool. Also has a LiDAR in there. Up to the age of, how old was he? 45, right? When you're a remote mobility engineer at NASA, aka the person that drives these robots on Mars, seeing something move when you tell it to across a long distance is always going to be magical, especially the first few times, especially when it's across 140 million miles. So that's what we want, right? We want to move things around, build a set of movement instructions, do something. So, took our graphing paper, started drawing a little path, and figured out, what is it that we can do here? How do we do navigation? How do we get from A to B? And what system should we be using? And that's really the hard part. Most of the time, when we think of race cars, toy cars, anything, you have a joystick. You have a wheel, you have something that is well understood. But what do you do when you don't actually see the device? When you have to infer what you want to do from a map that you have, which might not be live updating. I mean, 13-minute lag delay between us and Mars on a good day. On a bad day, slightly more. And that bad day, once it starts, it lasts for a while. So before looking at space, well, maybe we look what we do here. So we looked into navigation systems used by submarines, which most navies in the world are not super keen on telling you about. But luckily, there's some research that we can look at. And so, first one, sonar and LiDAR, right? Basically, you could use LiDAR underwater, provided your sensor is underwater as well. Has some upsides, has some downsides. So, makes you think, like, well, what are we gonna do with this one? Light pulses, sound pulses, okay, that could be annoying. If you have LiDARs that go at super high speed, you actually hear them. In our testing, that was not joyful, hearing that in the lab the whole time, especially if you misconfigure them or if they drop off the table, or as NASA calls it, is it the unscheduled rapid deceleration. These are all very important terms. It's also less painful than, say, you crashed it off the table. But because of the design of the device, we couldn't actually guarantee that LiDAR would see all the obstacles. There's a reason Tesla has their LiDARs in the front of a car and not on top, because at the top means it doesn't see anything that's below it. Not anything, but like anything that's too small. And we ran into that problem many times, quite literally. We miss obstacles that the code or the sensor just couldn't see. And it's also not a great system, sonar specifically, to use if you're being hunted underwater. Not a concern for us, definitely worth mentioning. We want to give you a full overview, everything, right? Option 2, much easier. Submerged beacons or beacons in general, sat-nav. very solid. GNSS systems work, GLSS, sorry, systems work for a reason, but they're costly. Seeding this room with beacons is going to take a lot of prep time for us, and we're just talking about one room. Also not optimal. Putting something on the ceiling, well, if they don't want us to switch off the lights, pretty sure they don't want us to climb on the ceiling, so also makes it hard. Which really brings us to, well, basically one final option that we can look at, which is what submarines do when they don't have access to maps. And it's also the most cool name, Dead Reckoning. Basically, a vessel calculates its position by looking at their current position, location, speed of travel, and direction of travel. Works generally well if you have some understanding of how the planet or how the body of water that you're in works, but errors accumulate over time. In our case, we'll use this because we had the map that we showed you earlier, and really, we kind of know what to expect, right? So we'll build with that. This is the hard part, though. The accuracy depends on a lot of different variables. If you've done a lot of programming, none of which interfaces with real hardware, you'll never have felt the joy of a motor that goes the same distance twice in a row after you handed it off to a colleague who has no idea how to treat that thing with respect. All those variables really, really affect the outcome of the movement plan. And, well, errors accumulate. So before defining our schema, took our map, threw it into Illustrator. We looked at a couple of mapping tools, and we designed pretty much the same track, and then mapped out how we want to move around it. I apologize if you're looking at this because of the light. The brown line might be a little bit hard to read, but imagine it's there, and imagine it's a drunk raccoon driving a car on a track, hoping to stay on said track. And you'll see we've got a couple of tight turns that almost give you, negative 90-degree turns that will barely keep you on the track. And we want to have all of those problems to figure out, can we make this move? And spoiler, the first version did not. The first version did not respect the sides at all, but we got amazing round trip times. The whole distance, given the optimal speed of the device, should be covered in about 40 seconds. We hit the goalpost after 7 seconds because the device just made a quick loop and went there, and that was it. Now, of course, if this was a race, you could take this shortcut. Not very sportsmanlike, but at least you're first, and you're saving yourself a little bit of gas there. And gas prices are rising, so it's fair, right? Not what we wanted, though. I think you described it as we shouldn't have any shortcuts like that in a hostile environment. Hostile being anything where, what if the white space there is actually a lack of road? What if there's a cliff, something that we don't want to crash off of, edge of a table? So we need to drive on the pre-planned track and make that happen. And so we looked at our track, mapped out a couple of waypoints. In our case, I think 34. And it's really simple, right? Using Dead Reckoning, we could zoom out a little and think of, okay, so what do we need? We need a direction of movement. We need an angle or bearing or something. And we need a distance. And so if we pop this into a JSON schema, because obviously how else would you describe this? Well, we got a name of the movement plan. Really simple reason. We wanted to see how one movement plan compared to another, and unique identifiers like that, helped us. And then a couple of steps. So direction, easy, right? Forward, backward, could be confusing depending on how you orient the device, but we'll go there. And a distance. You notice distance does not have a unit on there, which is a mistake that we thought we could correct. We could not, but we'll get into that. I think you're going to talk about that later. So 3 question marks is obviously one of the coolest keys that you can use. It's not very descriptive, so let's experiment a little bit here. Option 1 is we use bearing. Sounds cool. Doesn't really work though. If you look at where the 0 is to the green arrow, you'll notice that we're going to the right, but we're at 45 degrees. That's because our true north is not in the direction of travel. Now, this is not a problem on any planet that has a strong magnetic field, because your compass will always tell you with a high degree of accuracy how things work. On Mars, that would be a problem. Magnetic field is too weak to use actual magnetic navigation. So in our case, that's out. Much weaker than Earth's magnetic field, only on the South Pole, I believe. Would it be barely strong enough? Yeah, and we don't want to build stuff that may work if you're on the right location. We want to build stuff that works consistently. Not that we're getting there, but yeah. So we'll switch it to angle. Dead reckoning goes well with angle, and things get a lot easier. If you look at it, we're traveling to the right. Our device is oriented to the right, so there is no angle change. If we add a second step on there, which gives us this one, we have an angle of minus 50 degrees because we're turning to the left from the viewpoint of the device. We travel forward, distance of 10, and it's easy. Repeat that about 32 more times, and you'll have the full track defined. Joke's on us. The chip we used was so cheap that we could, at most, consider a payload of 20 steps before the CPU would give us a Guru meditation overflow error. So that was great. But in theory, had we invested in more expensive chips with more than 2 megabytes of application storage, we could have made this work. And of course, like any good engineer, we drew it, we tested it, we wrote it out, we documented it. It's very important, because only that way could we have actual conversations about this with our whole team. So we figured, well, we've got this movement plan. Angle and bearing is very confusing. There was a period where we didn't touch this for about 2 months, and when you come back to a project like this, your head goes to what it knows. I think you went to bearing, and our code just didn't work because the code was expecting angle. So having it documented when it's fresh on your mind, free career coaching, do it all the time. It makes you a better engineer. Future you will thank you, and past you will also be grateful, because you're going to be looking back at this project not thinking like, why did I do this? But you'll understand why you did it. But angle, direction, distance, we're not taking a lot of stuff into account here.
And even with that not very complicated instruction, there's a lot of things that can go wrong, like really a lot, and we went through a lot of them. So the first one is the distance traveled. First you need to have a common unit of that distance, like Karim alluded to earlier. When you have one contractor using Imperial and NASA expecting metric, fun stuff can happen, like maybe you lose a spacecraft. In our case, it just runs off the table, so it's not the end of the world, but still, if we can avoid it, it's great.
But it was the end of the table.
Yeah, but we didn't maybe lose it entirely. Like, we could salvage parts of it, so not the end of the world, but still, it's important to have a common unit that everybody knows, understands. You preferably have it in the specification directly documented so that everybody knows what to expect. The movement doesn't happen in a vacuum, depending on the environment, on the carpet, the table, if there's rain, if the humidity is different, the distance traveled will be different, potentially. And also, the rover has inertial measurement unit, so it knows what position it is in, and depending on the position you're in and the environment that you're in, that might or might not be accurate. So you can have also some fun stuff there to account for. So then the power of the motors also depends on the battery level. So half speed at full battery and half speed at almost no battery are different speeds. And it's not documented what those speeds are, and of course they also depend on the carpet and the table and etc. So we had to test all of this and account for it in the code, which, yeah, again, not necessarily obvious. Also the device itself, the wheel fairing on the initial version wasn't a very good quality, so it was plastic. So it was quite easy to damage, so we tried 3D printing stuff, improving, but yeah, wasn't enough. This one is full metal, so survives a little bit better when we have unscheduled downward motions and full decelerations, runs off the end of the table. And so all of these things have to be counted in the software that we write. Like, there is no magic easy way, say, run at a consistent speed or account for the carpet friction. So this is part of the environment. The traction, depending on the type of surface we have, will be wildly different, which was fun to discover. Like, of course, it's obvious in hindsight, but not always when you're there. So also the environment, in this case, we have a carpet, we have the cable. The way that the cable is, depending on the positioning of the rover, the LiDAR might not see it at all and might not know that it's something to avoid. In this case, maybe not, but if it's something bigger like a pen, it could be an issue. And of course, there is also inference. Like, we're in a conference room, there's a bunch of equipment, you probably all have phones, there is Wi-Fi, Bluetooth, and all of these cool things which result in inference. So we need to account for potential disruptions in the communication between the rover and our control unit. Handle gracefully if there's any failures around this, and not just crash or run off the table if we lose connectivity for a second. And also, of course, the distance, because it's still an embedded device. Yeah, it has a big pointy antenna, but still, it won't run well over long ranges for now.
And so one good thing to keep in mind there that we discovered early in our code, when our network connection would drop away while sending instructions, the last instructions would be repeated until new instructions were sent. Which is great if the last instruction was to stop and halt and stop movement. Not so great if you're losing connection because somebody's rebooting a router or something else happens and you just can't get to the device in time. Emergency stop code is definitely worth having and building into your systems. That big red button doesn't have to be a physical button, just an API call that allows you to shut everything down. Definitely useful.
And also a dead man switch. If you lose connectivity for too long, just stop, because, yeah, don't know what's happening. So we also have, we've accounted for all these things. It was not very easy, especially in C++, especially with no modern IDEs, no ChatGPT to help really. So, but we've managed to do all of this. It took us a couple of months, but yeah, we're there. But we already have a list of improvements, stuff that we would like to do to make this even better and more fun. So, as Karen mentioned, we've already started adding cameras. We're using cameras from Siege Studio, which can run object detection models directly on the camera itself, so it saves us some compute. So we're going to try to add, computer vision and detect objects to avoid or people to run over and stuff like that. on top of the cameras, because cameras are good, but if it's dark in the room, they won't see anything. So we're also going to improve the lidars, mostly their positioning and decision making based on the information from them to better avoid any potential obstacles, or if there is a potential obstacle, go back and stuff like that, to avoid driving off the edge of the cliff or a table, or going into somebody, or getting entangled in cables. And communication, I already mentioned this briefly. In a place like this, Wi-Fi might not work well. Over long distances, Wi-Fi does not work well. So we're considering adding LoRa for long distance communication, and potentially, hopefully, more reliable communication, especially in dense environments.
Let me grab this one real quick. And so, the fun part that we realized, we deployed an army of these at an event in October, about 12 of them, but they didn't talk to each other. And that's always the sad part, right? You've got 2 robots, some of them adorned with rubber ducks. We should do something fun here. So ESP now and other technologies give us access to the basics of swarm logic. So we figured, you know what? We've got 3 of them. We'll have a leader and 2 that are basic followers that just do what they need to do, which is always beautiful. But the more interesting part is, this being the bigger version. Do you want to bring her up? This being the bigger version, sometimes you don't want to sacrifice the big one with all the cameras. You want to sacrifice one of the smaller ones. So we figure swarm logic could allow us to test certain things where we bring a smaller one forward that then communicates the things it finds back to its leader. She's a little bit shy, as you can notice. A lot of people, which does freak her out sometimes.
And the carpet makes for not great friction.
Still better than sand. And so, of course, I think you want to go the other way. There we go. See, Matthew doesn't bite. The next step here is, of course, edge computing is fun, and having those small cameras be able to process what they see at the edge, very cool, but still very underpowered. There's only so much processing you can get out of a device that's $50, $60. So what we're working on is this beautiful case, about a third bigger than this case. With recent changes, I did not want to tempt my luck with TSA, so I did not bring this one. But basically what we have in here is an AI accelerator, built-in network built-in network access point, and everything else we need, which really gives us access to all the processing we need for these devices. And of course, because it's a standard computer running, in our case, Ubuntu, life gets really simple, right? We're no longer forced to use crappy code. We can just use any normal application. We've got a 10-inch display in there that you can tap, and it's a self-contained unit. Backhaul via network, which then gets provided from this device, so all the rovers can connect to it. And because we've built a couple of these, also easily connected to a LoRa access point, so should Wi-Fi fall away, should Bluetooth fall away, we can still use LoRa networks and Meshtastic and everything else. Do you want to bring her back? Yes. We, all of these were named by my daughter. This one is called Cat, for no reason other than our neighbor have a black cat. We spray painted one white, which is called Lucky because that's our other neighbor's white dog. There we go. We're not currently recording it, so we are?
Yeah, it's recorded.
Oh. Right. So,
You or somebody you know has been hurt by a roof.
yeah, I should have probably prefaced this by saying Adrian and I are aware of the laws of robotics. Our Pathfinders are currently not. They will run themselves off the table and hurt your toes if told to do so. But yeah, that really brings us pretty much to the end before we get into questions and everything. If you weren't paying full attention, you could totally think this talk is all about the ins and outs of controlling robots and all the stupid stuff you could do by improving code that somebody else wrote and bonding with somebody over the internet. It wasn't. This talk is really about building a system that is able to deal with a lot of variables that you have no idea of, the known unknowns, and very much the unknown unknowns, like, will all 10 that I ordered behave in the same exact way, given the same software and the same battery charge? There's a lot of experimentation to come to a very clear answer there. That answer is no, they won't. Especially once people start lifting them up, handling them, and encouraging them to seek the tolerance limits of downward acceleration. This model is currently one of 2 that are still functional, but we do have the parts of 12 other ones. Yeah, ultimately, all of this to say that experimentation is important. We're normally dealing with stuff in the cloud, multi-cloud deployments, multi-continent deployments, everything that's very easy, very predictable. Nothing is as fun as seeing this little rugrat drive across the room and knock somebody's water bottle over. Purely hypothetically speaking. No, but seriously, once you get into challenges of like, what kind of data can I collect? How do I collect it? What do I do with that data? Collecting data is easy, right? Buy a 2 terabyte SD card, it's $200 at this point. You can collect for the end of days. But what do you do with that data? What do you do to make that device smarter? Can we turn this into a toy where if I throw a ball at it, it notices what a ball is and uses its grabber to either pick up the ball or bring it back? If you're on the East Coast, this small college, university, they do a lot of that stuff with a couple billion in funding. Turns out you can do a lot of that for less than 500. I think this one is 300-ish. With all the stuff we add on, maybe you get to a 500. There's a lot of fun that you can extract from that. So as an engineer, if you feel you need a new challenge, get into this kind of stuff, have some fun with it, and learn from it. And to give you an idea, what we already had part of the demo, the interface Adrian is using kind of looks like this. Also works with a joystick, or joypad, sorry, not joystick. That'd be much cooler. Allows us to set speeds. I'm going to set it to high speed and see if we can cause some damage.
That was the high speed.
That was the high
carpet
speed.
is really...
Carpet is not a friend. Got it. And of course, we've got a bill of materials, all the code that you need, everything. It's still crappy code. It's getting better. PR's welcome. But we do have the complete code base for this and the smaller units available. All open source, of course, because that's how it should be. Because ultimately, that's how we learn from it. And that's how we hope other people can learn from it. And with that, I think that's time for questions.
Thank you for the presentation. Just a question about, in the future, you guys are thinking of doing AI and edge computing more. Have you guys talked a little bit about Jetson Aura and Jetson Aura Nano? Have you guys tested that out, or is that something, are you guys going to stick with the ESP and just do that, or?
We're using, so first of all, great question. I'm glad you have the mic because I don't need to repeat the question, but so we're splitting the computational workload in a couple of different systems. The ESP32 is great at receiving very simple instructions, doing stuff with it. So all the movement is already connected to it. Running that under something more powerful like the Jetsons, not great, so we keep it on that simple chip. Also because if we fry it, not a big issue. The Jetsons, on the other hand, and Pis and the Pis with the AI accelerators, full-blown computers. So we let them handle the workloads we understand. So if you want to run something like, well, any model through Olama, we'll just spin up Nomad, run the workload that way, and experiment with it that way. What we've done is we put one of the CJ4012s on there. It's like AI accelerators about this size and, what is it, like 1.5 pounds probably? So it works. The device will happily chug along, but speed goes down. Plus you're now running a robot that's 300, running a piece of hardware that's about $1,000. So that's not great, which is why ultimately, in this case, what we're doing here is this is that same accelerator. As long as we have data connectivity between this case and the robots, we can do all the processing we need, especially if you switch to something like LoRa, for a simple reason that pretty much everywhere you go, unless it's an industrial plant, LoRa is not contested. So that is the approach that we like. Great question.
Did you guys ever hear of something called Robot Operating System, or ROS? And if so, could you talk about how something like this would work with ROS?
I think a lot easier. So ROS is definitely a great approach. The reason we started out with the code that's in here and started improving that is because, like most projects that you do in your spare time, we figured, you know, it's Thursday, we could have done all of this by Sunday. And that was true. That Sunday was sadly not the Sunday 3 days later, it was the Sunday about 4 months later, at which point we decided, you know, this is where we're going. We also wanted, from an engineering perspective, the challenge of figuring out a lot of this ourselves, simply because it allowed us not so much to reinvent the wheel. The whole reason this is working and driving is because we're standing on the shoulders of giants. People much smarter than us that understand a lot more about this, that build code samples and libraries that we could improve upon and build upon, but still have the challenge of figuring out how do we make all of this work? What are the things that we can use for a conference? We built a Terraform provider so people could define their movement plan in Terraform code and run it and see who would get the fastest time. And I think that the whole learning experience was worth it. If I would do this in a semi-commercial setting or just in a more structured way and actually make this, you know, like a after-school club, 100% ROS too. Never go down the rabbit hole of writing this code myself again. Sorry.
I was wondering, I saw that you were using a YOLO model, which version you're using, if you're using one of the pre-trained COCO models with it?
One of the cameras, so yes, great question. 11 currently on the camera, primarily because that's what it was pre-built with. And so for us, it was easier to get that. And for people detection, all we care about is there a person or not? We don't care whether that person is happy or not. We do know, we can infer from our own experience, if it hits your leg, the person is not going to be happy, but there was no training needed for that. A lot of treatment, though. So ultimately, for us, that approach was easier. But of course, the cameras are all open source, the hardware is open source. So once we decide that we want to put a different model on there, that's what we're going to do. We've been experimenting with a version of these that we call L'Explorer. So basically the idea is you build a small scene on a table like this, on a smaller one than this, like Lego figures, like, you know, a giraffe sitting in a train. You drive the robot past, it sees that, and then turns that into a visual storytelling device. So For kids, you build the scene and like you now get the story where your giraffe is a heroine that saves the town by driving the train and picking up all the kids from school, something like that. Definitely requires custom models because most models are not trained on Duplo figures. But yeah.
And did you happen to train anything so it would recognize itself, like one of the other versions that you had running around?
We have not currently, well, they do recognize each other in the sense that obstacle,
Yeah.
but not in the sense that I see the other one here, I can do something with it in a visual way. Through Swarm Logic and ESP Now, they can connect to each other, they just don't know who's who, which the way we want to solve that is by giving them different colors, because then with shape plus color, you should be able to detect something. Another thing we looked at is, and Matthew and I joked about this, we should install one of those infrared flashlights, because with infrared paint, you can put a specific marking on there that if you recognize that, nobody will ever see it, but the robot sees it, and that's what matters. One of the bigger options to build, also a lot of fun. But yeah, it would be nice if they recognized each other and knew that the green one has the arm capability, whereas the blue one has the, instead of the arm having a gripper, has a camera on top. That might be a SCaLE for next year.
So I apologize, I missed a little bit of your presentation, so I might say something that you might need to repeat. But so you open source this project and we could do PRs. Do you guys plan to do like some people, they don't want to build the whole robot up and then do PRs. Do you guys plan to do a simulation or something we can use to...
Are you thinking digital twins?
Yeah, like a digital twin, exactly.
We looked into that, mostly because 8 years ago, working at the Amsterdam airport, when you work with sewage pumps that are $500,000, you have to have digital twins for everything, because firmware upgrades can get really shitty, pun definitely intended. We don't have enough data to build one, despite many IIoT vendors saying, just upload a JSON file and we'll give you a perfectly functioning digital twin. So the way we cheat that is, ultimately it's an ESP32. So that's what we order, a strip of 20 of those off of Amazon. We can still run the same commands. Obviously, if there's no motor attached to it, they won't behave, but at least we can test that the code works. So even when we were on a flight, if you pull this one out, people are going to have questions. Very likely the air marshal would like to have a word with you, which is understandable, right? I mean, it's a black device. It's not a common sight. Whereas if you pull out one of the, let me see if I have one with me, one of these tiny dev kits, you can still write the same code, test the same code, and nothing happens because nobody sees it. Not a digital twin, it's more physical twin.
Yeah. You're just testing the signals out to make sure everything's
Yeah,
good.
exactly.
Gotcha.
It's definitely a cheat mode, but it's also the cheaper cheat mode because frying this one versus frying that one,
Yeah.
just replacing it is annoying. So, yeah, I'd prefer to have a complete virtual version of it that I could run all commands against and see, is the arm working in the way I expect it to? Because of course, you write some code for a gimbal and the arm extends and then you're like, oh, well, that's great because, it's mounted to my desk. When it's mounted to the device and it extends too far out,
Falls.
it tips over
Yeah.
and then you end up like Athena, which is not a great feeling.
Yeah.
But yeah, if you have any idea on how to do digital twins, definitely would like to pick your brain.
Okay, awesome. Thank you so much.
Thank you.
Okay.
So the software is open source. Is the hardware also open source, or is it just something that you can attach onto any hardware that works, that's compatible with the ESP?
So you can use pretty much any pulse width modulation-based motor. I would highly recommend getting these ones. The reason we bought commercially available hardware is because it's in plenty supply. Adrian lives in Paris, I live in Amsterdam. We had a team in Orange County also working on it, well, team, 2 people. All of us could get the same hardware easily delivered, and when we broke it and drove it off the table a couple times, we still could get easy replacements.
So it's completely possible to 3D print a chassis for it, for example, and use the software you provide?
There's an SCaLE available, there's a, what's the other one? Something in USDC format. If that works for you, let me see if I can pull that one up real quick. But the long and short story is yes, you can, which is where this gets a lot more fun. Though I would recommend not printing a chassis that's not out of metal, simply because of the speed of the device. And let me see. Sorry?
I said, what were all the injuries you guys suffered? Toes?
Cut open finger at the top, grabbing one of the chips on the wrong end and puncturing the skin because, well, there's a reason we now have tape on these, and blank headers, because we truly care about keeping ourselves sane. Let me see if I can get that moved over, and if I can get my cursor somewhere. There we go. So with this, you can just explode it. Actually, you know what? We're gonna use a real program for that.
Did one of you guys do that? Is this AutoCAD or?
Oh God, no. Building this from scratch is at least beyond my skill set. Modifying it a little less hard, but basically Waveshare, who makes these robots in different flavors, has all of these things available, which then allows us to pre-print or reprint the parts that we care about, and also customize them. All of them are black, but if you need a different powder-coated one, it's easier to just, send the specs to somebody and get the case instead of taking it apart. And the software, initially when they released it, their demo software was basically a zip file they uploaded to the site with crappy documentation. After some prompting, they licensed it under GPL, which made it possible for us to fork it, make contributions, push those back. 9 months on, our PRs have still not been reviewed, so we decided to just open source our version of the code and bring the code to other people that way. Lots of good injuries, and each injury is a learning. I think the hardest part is because it's 2 millimeter thick aluminum. When it tips down and hits your toes, you're gonna feel that for the rest of the week. Worth it though. Let me see if yeah, that and the acrid smell of burning plastic. It's the beauty of working with hardware. You get to debug and use fire extinguishers. But yeah, definitely, if you want to 3D print your own, models available, do it. It's good.
Any other questions? We're at time, but it's lunch break now, so if anybody has one more last question, we can do that. If not.
All right, thank you everyone.
Thank you.
Thank you.
How long has it been since you started it?
Test, test. Hello, hello. Hey, that's really good. Yeah, I don't even have to, I can just be nice and quiet. First try. together, didn't we? Yeah, here we go. Yeah, it looks like things are, yeah, look at that. We're good to go, yeah. Thank you.
We're all good?
All right, thank you. All right. I think it's time to get started, let's go through our checklist. Can everyone hear me all right? Is the volume all right? All right. Next check is can everyone see the screen okay? Is that working all right? Okay, third check, are there any sodas in front of the projector? No. So I think we're good. Okay, we can get this started. All right. So my name is Kyle Rankin. I have been involved in Linux for like about 25 years or so. In the past, I've written a number of books for a couple different publishers on Linux. Some people might know me from my Linux Journal column I did for many years. Right now I work in computer infrastructure and security. But that's not what we're going to talk about today. Really, we're going to talk about using Nextcloud as a self-hosted cross-platform cloud. So first, thank you all for coming. I really appreciate everyone coming out. Last track of the day, of the last day. So after lunch, we'll see what we can do to keep this as entertaining as possible, since you're going to start digesting here in a little bit, and it's a warm room. There's some white noise. It's going to be, and my voice is very soothing, I know. So we'll see what we can do. All right, let's go. All right, so as an introduction, I'm a long-time self-hoster. I self-host a lot of services. So I've, for the longest time, self-hosted my own email. I've self-hosted my own websites, DNS, because I'm a sysadmin, right? And so it's not labor for me to host my own stuff, because it's what I did for my day job forever. So it's very easy and straightforward. And I set it up a long time ago, all these services, when I first got into systems administration. So maintaining it for me is no big deal, right? It's sort of like, you might be surprised if someone who's a mechanic by trade doesn't change their own oils. Yeah, this is no big deal. I do this all day long. I can do it on my own car. It's not a problem. That said, I did use some big tech groupware type stuff. Mostly I'm talking about things like Google Calendar for the longest time. If you would get an Android device, it's very convenient to use your Google account to have your calendars be there in sync, and then you can share calendars with people, and that's a really common use case. And it's I didn't ideally like to do that. I had some sort of questions about the fact that I was sharing all the things that I did in my life with a provider that was going to obviously market based on that, but I still used it. And then there was this process I went through where I was how could I reduce or completely remove the amount of Google in my life? I think a number of people, maybe 5, 6, 7 years ago, or started this sort of process of re-examining when people started becoming more aware of privacy implications of some of these services. How much can I reduce my dependency on this? And so in my case, I started looking around and started grabbing these different areas where, do I really need to use Google for this particular thing or not? Can I find an alternative? And in particular, one of the ones that I was left with was I needed some sort of shared calendaring solution that wasn't Google Calendar, because my wife and I both had been using Google Calendar with our accounts, and that we would share our calendars with each other. It kind of makes sense. So looked around for alternatives. This is a number of years ago now, and I discovered Nextcloud. Well, I kind of knew about Nextcloud, but I realized, you know what, that actually might be a good solution for me just for calendaring. So tried out Nextcloud Calendar. And then as my extended family started adding other devices, in particular Apple devices, we started expanding our use of Nextcloud to make it a little bit easier. There's a lot of things which we'll get into in the talk about why this is beneficial, but how we use Nextcloud started to change when we started adding these other devices into our family. And now I would say that Nextcloud is probably critical, if not just key, but probably critical to having this really easy cross-platform life where we have all these different devices with all these different operating systems. I'm trying to get them all to integrate really well. I found that Nextcloud to be kind of central to that. It's essentially in many ways like a self-hosted iCloud. There's a lot, it doesn't have 100% of the feature sets that iCloud does, but it also does some things that iCloud doesn't do. But all of the things that you would typically care about from a syncing between devices type thing, it does really well. And so it has a lot of the same features. So in this talk, I'm going to talk about what Nextcloud is, talk through some of the self-hosting options that you might want to choose if you want to do it yourself. Talk about my setup in particular, sort of like how I host it. Then I will discuss a little bit on how you integrate Nextcloud with Linux. That'll sort of lead into a general purpose discussion of the native app. So Nextcloud has a native app for many platforms. And so I'm going to talk a little bit about what why you, there's a couple different ways that you can integrate with Nextcloud, and the native app is one I'm going to talk about, why you might want to use the native app. Then I'm going to talk about how to integrate with the Apple ecosystem using Nextcloud. And then finally, I'm going to give a couple of actual real-life anecdotes from myself and my family of how we've used Nextcloud to have like a nice cross-platform life. So what is Nextcloud? So Nextcloud is an open source groupware solution. It was hard to, because the word cloud has been so overloaded these days, like I was like, what's the actual word for what I'm talking about? I guess I'm kind of talking about groupware because that was like the best word I could come up with for kind of what it does, because it does so many things. But it's a similar feature set to like Google groupware, so how Google would have like calendaring and the docs and things like that, and also iCloud, like I mentioned before. By default, you have this nice web-based UI. It's very easy to use. You log in, and you can do pretty much everything that you would want to do from a web browser. That said, it also has native integration with native applications for all the major platforms you'd want to use it on, so that you can integrate with Nextcloud that way as well. There's also a big community around Nextcloud. I mean, this is not a brand new project. This has been going on for many, many years. There's a lot of third-party modules that the community has developed. There's extra modules that Nextcloud itself has developed that can extend what it can do beyond just sort of basic feature set, which is already pretty great. So some example modules, some of these are third-party and some of these are core modules, but these are the ones that I've personally used with Nextcloud is files. So this is similar to like a Google Docs type feature where you have a web-based UI that you can go in, you can store files there, you can view those files, you can share those files with other people on the internet, you can get, or other people that have Nextcloud accounts with you, you can share the files with. You can also provide shareable links to people outside of your account. If, it can be a nice solution for that. And so in general, it does a lot of the things that GDocs might do for you. Calendar, we talked about that a lot already. It has a nice web-based calendar application that's pretty easy to use, and calendar integration. Contacts, so you can share and sync contacts with Nextcloud. It sort of goes part and parcel with calendaring. You want to have contacts as well, and it has a great basic contact web app. It has an office suite. There's actually a couple of different modules that provide this in different ways, but you can essentially think of this how Google Docs, or I guess Files is closer to G Drive, where Office would be more like G Docs, where you can live edit. You can not just go to Files and see that there is a document or a spreadsheet. You can actually open that within the web UI and edit it just like you might on like Google Groupware or things like that. It has that feature. News. So I was one of the many people that were disappointed when Google Reader was killed. That was the way that I read my news forever. I loved the fact that it had VI key bindings that let you JK up and down the news and go next story, next story. You just, in great RSS, web-based RSS reader for news. The way that it organized news was great. And when it went away, I very much missed it. And obviously there's 5 million alternatives to it that are trying to mimic the functionality. However, one of them is Nextcloud News, and it provides a lot of the same types of interfaces that would be used to with Google Reader, and this is what I use for my RSS reader now. And there's a mail application. There's actually a couple of different third-party mail modules that you can use, but web-based email, like you might be used to in other platforms, you can plug it right into Nextcloud and have it all there. So. One of the reasons we're talking about this here is to self-host this. One of the reasons I wanted to move away from a third-party provider was I wanted the ability to have more control over what I was doing and my data. And there's a lot of different options that Nextcloud provides. The details are actually on their site, so I'm not going to go into, here's how you install it this way, here's how you install it that way, because however you want to do it will be a little bit different, but you can go to the site for details. But for example, there's some third-party Nextcloud providers that if you would like this feature that holds only your data, but you don't want to go to the trouble of maintaining and administering it yourself, there are third-party providers that will provide Nextcloud as a service essentially, that through presumably some fee, you can pay them, and then you can have an account on their cloud, as it were. There's also self-hosted cloud options, and by that there are cloud images, for all the major cloud providers that you can get to where if you have a cloud account on like AWS or whatever, you can host it yourself without having to worry about infrastructure at your house. So that's an option, and like I said, the website lists a lot of the different choices there. And then finally, there's self-hosted hardware options. There's a couple of different avenues by which you can install this server on a lot of different hardware, including things like Raspberry Pis, like especially now that, I mean, you've been able to run it on a Raspberry Pi for a long time, but now that Raspberry Pis are incredibly capable, like big, fast computers, it's actually a really good choice for many people, especially for just like your home and doing things like that. But Raspberry Pi, regular server, anything that runs Linux, they have install options. The thing I really like about Nextcloud is, from an administrator standpoint, compared to a lot of the other self-hosted things I do, maintaining it is very simple. It's very easy to upgrade. They've done a lot of I wish actually a lot of other services approached upgrading the way that Nextcloud does, and made it as easy to use. When it's time for an update, you'll get like a notification. In the interface, you can go to the settings, and it will tell you about the upgrade, and you just basically say, yes, please upgrade, and it does all the things you would want to do as an administrator to properly upgrade a system, like go into a maintenance mode, perform a backup, download the thing, check the integrity, all those things, apply the changes, then exit maintenance mode. It does all of that for you within the web UI and tells you that it succeeded, and then you move on with your life. So you don't necessarily have to be some sort of hardcore sysadmin to host this yourself. Everything is done through the web UI. You don't, after you install it, and maybe not even after you install it, depending on how you install it, you may not have to interact very much with the terminal if you don't want to administer this. All right, so what's my setup? I host it on a home server. What my home server has changed over the years. So, early on I had like a 26U cabinet, and I had like 1U servers, and I had a crazy power bill. But I was, I was like I was the sysadmin, I was like practicing as sort of like self-training stuff, right? Everyone does that that's into system administration at some point. Then the power bill got crazy, and so I started downsizing. So then I did all these system-on-chip things, like Raspberry Pi-like things, so it kind of went all the way to that, like super low power setup. And then more recently, I was like, I started pricing out, I started getting some power outages every now and then in just my neighborhood for various reasons. Like, I have a UPS, but with even my low power setup, it's only lasting like maybe an hour and a half, which is pretty good. But like, well, what would it take for me to get like an 8-hour UPS, right? And you start pricing that stuff out, and then the space and everything else, and it gets kind of insane. I was like, wait. You know what has an 8-hour UPS, a crash cart, and everything else that you would need for a great home server is a laptop. So my current home server is a ThinkPad E540. It has 8 gigs of RAM. I got it on eBay for $38. The great thing about old ThinkPads in particular is, for a server, is depending on the product line, they have Ethernet ports, usually have gig Ethernets. So in my case, this does a couple of things. So I also have an extra dongle to get, so I have 2 Ethernet ports. But basic server, Ethernet ports almost always included. It's popular among the enterprise, so you can always get used ones pretty cheap if you go back a couple of generations. Linux support's almost always great on these old ThinkPads, so you don't have to worry about that. And so yeah, in my case, that's my preferred home server setup now, is some sort of old ThinkPad, because again, when the power goes out, it's going to last for hours. Even when the UPS dies, it's going to last for hours and hours and hours after that, because it has a battery in it, So in my case, there's a couple of different ways that you can host the data for Nextcloud. The default is to like a local sort of file system thing that doesn't rely on a database, which is nice and simple. For my setup, I started that way, but then when I started getting more serious about doing more heavy-duty use of Nextcloud, like a lot of files and a lot of shared other people using the service, then you can also have a MariaDB database backend. So I switched over to that. So that's how I host it myself. I happen to have gig fiber internet. Thank you, Sonic, for providing that in my neighborhood. So that's pretty nice. So for a home server, that means that I feasibly have reasonable speeds if I'm hosting it out of my house. And also, Sonic's very friendly to people who want to host services off their network from their house. They're not trying to find and block ports and stuff. Also, because I'm a system man, I have proper DNS set up. I have HTTPS certs from Let's Encrypt. So all of that is set up on mine, which means I can access it externally. So I have like an external DNS endpoint. I can go to that URL and I can access it from anywhere in the world if I want to. That said, I mostly use it internally. Most of my file syncing happens on my internal network. I really only sync with it remotely if I'm out and about and my phone may be syncing to it or whatever, checking calendars or something like that. But for the most part, most of the bandwidth is internal. So even if you don't necessarily have gig internet, Ethernet at your house, just the fact that what you're going to mostly use it for is it locally, internally. You don't need a lot of bandwidth normally unless you're syncing tons of files all the time outside of your home network. So how do you integrate with this with Linux? It's pretty simple, thankfully. If you are, for example, if you're a GNOME user, it's very easy. In GNOME Online accounts, it is one of the account options. In fact, it's the top account option. And you basically just go through that UI. You say, yeah, I would like to connect a Nextcloud account. You tell it the server name, and you tell it your credentials, and you're all set up. There is a chance sometimes I've experienced, sometimes it just works fine depending on the system, and sometimes I find that it might error out by saying I can't find the webdev or some error like that. And find in general across all of these OSs, if you get some sort of weird error when you're first trying to set this up, it's usually because it is trying some sort of default path that isn't the default path that Nextcloud uses for this service. So if you see that error, you basically just manually enter in the full URL, which is whatever your hostname is, remote.php/dev, and and then it'll work. When you do this, the host that you do this on will automatically set up calendars and contact syncs. So if you set this up and then you launch the GNOME Calendar app, boom, all of your shared calendars and all of that stuff will start showing up there. Same with you open the Contacts app, all your contacts will start showing up there. In addition, when you open files, there's going to be a Nextcloud item in sort of like the tray, the bookmark tray on the side, where it will provide a web DAV source to all of your files. So you can click on that, and it sort of does a DAV mount, and then you can sort of traverse any files you've synced from somewhere else. You can traverse all of those from your host. Now, maybe you don't use GNOME. There's like everyone uses something different. That's totally fine. Obviously can't provide an exhaustive guide of how to do it with everything, but in general, things have some sort of DAV endpoint. Whatever app you're using for calendaring or contacts, you would either use their CardDAV or CalDAV support. So CardDAV is a API, a protocol for syncing contact information, and CalDAV, same sort of thing, only for calendaring information. So if you have a calendaring app, it probably has this natively built in. It should. If it's a decent one, and then you can just use that and it'll sync. So for example, this picture's for KDE Contact, which is their contact management system. You can see here how you would use it. Some apps are even, especially on Linux, are OwnCloud or Nextcloud aware. So OwnCloud and Nextcloud are sort of siblings. There's like in a lot of open source communities, there's like there's a fork, and sort of Nextcloud sort of went their own way from OwnCloud, but enough of the fundamentals are the same that that a lot of software has OwnCloud support, or they maybe call out both OwnCloud and Nextcloud kind of interchangeably. So if you see OwnCloud instead, you can probably use that if you don't see a Nextcloud specific option. All right, so let's talk about the native app. So what we did so far, we didn't really have to install anything on a client. We just sort of pointed it at the server, and everything synced. But there is a native app, and it's pretty useful. It's available for all the major platforms you want: Linux, Windows, Mac OS, iOS, iPadOS, Android, a lot of different platforms. And what's cool about the native app is what it does is it sets up an automatic bidirectional file sync. So without this, you can go to the Files app and browse and see your files, and you can access them, and then when you access one, it will download it from wherever your Nextcloud server is and then load it. What this does is it'll create a local folder in your home directory called Nextcloud, and you can tell it which of these folders do I want to keep in sync. And that means when you make a local change, it then gets synced up to Nextcloud, and any other clients that you have out there that also have this Nextcloud app can sync that change down to them. And so that way, all of the files stay in sync across however many devices you have that have the Nextcloud app installed. How do you get it? This is generally available in most distribution repositories I've seen, or app stores, or whatever way that you get your software on a system these days. But if for whatever reason you use a special system that doesn't have it in the store, then you can also just go to the Nextcloud install page, and then they provide basic instructions outside of all of that. Like I said, this keeps a local copy of the file of all these files on each device, which is really nice. However, depending on the size of your files, you may or may not want to sync everything to every device. So say, for example, you install it on your phone, you may not, but you have many, many gigs of files that you're syncing with Nextcloud. You may not want all of those on your phone, but you may want some of them, and you can select through the app which things stay synced on this particular device, which is useful for things like phones. By default, though, if you do have a file share that is a directory that's larger than 500 megs, it will prompt you just to make sure, are you really sure you want to sync all of this data down? And then you say yes, and as you can see here, I have quite a few directories that are pretty large, and it has no problem. I do recommend, so this is like the key for the cross-platform cloud. I recommend, obviously syncing it. If you have a local server on your local network, it's better to do the initial sync on your local network instead of over the internet somewhere if you can, but it works. But yeah, I would say that this app, more than even like the calendaring syncing and stuff that you can do, is key if you want to move between different platforms. It's one of the things that made it so easy for me to move, and my family to move between different platforms, because all of our files stayed with us wherever we were. If we made a change to a file on this device, it automatically showed up on all of the other devices. So how do you integrate with Apple? So there's a couple different ways depending on which OS. So on Mac OS, for instance, there's an official guide. I've noticed sometimes I've gotten errors when I've followed the official guide. Not that necessarily there's anything wrong with the guide, but I can't always vouch for that it's up to date. Maybe it is. I've just hit errors every now and then. Again, usually because of DAV URLs and things. The thing to note is that on Macs and on iOS as well, Nextcloud needs to have HTTPS. These days, they do not allow CalDAV and CardDAV syncs to an HTTP endpoint, so you need to set up a legitimate valid cert, or if you have some sort of self-signed cert, which these days with Let's Encrypt, it's pretty straightforward. If you're going to go to the trouble of building a self-signed cert, you could go to that same trouble and get like a legit cert. So I recommend doing that. So what you do is you go to Settings, Internet Accounts, Add Account, and then there are two different types. There's CalDAV and CardDAV accounts listed in there in Settings, and then you pick each of those independently, and you basically just add your credentials and the URL, the location for your Nextcloud server. If the sign-in fails, which it could, and I've experienced that, if the sign-in fails, you'll get some sort of error that maybe the error doesn't make exact sense anyway when you're looking at it. If that happens, move to Advanced Settings and set the URL manually. Here's what the URL would look like. So that URL points it directly to the DAV endpoint, and that tends to satisfy whatever errors it has. Because again, I think some of these, my theory is that Nextcloud happens to use a different DAV endpoint than maybe some of these other services are expecting, and so you have to point it out. Often it doesn't auto-discover. Once you do this, what you'll notice is your Mac all of the native apps that you might want to use this have synced will sync. So for example, contacts, calendar, and reminders will all start showing up, your calendar events, your contacts, and with reminders, if you install the Nextcloud Tasks module, then even your reminders app will have an entry where you can start creating tasks that will sync between your devices as well. And then the next step after this would be to install the Nextcloud app from either the Nextcloud site, or if you use Homebrew, you can use Homebrew to install the Nextcloud app, which I would recommend here. Let me go back to that for a second. So the nice thing about actually I'm going to talk about this later with iOS, so let me go to iOS first, then we'll talk about the app. So with iOS, calendar and contacts are very similar. The steps are almost identical. You basically, to set up the calendar, you go to, on your iPhone, you go to Settings, Apps, Calendar, Accounts, Add Account. And And then these are very recent instructions. If you've used iOS for a while, they moved how some of these settings are, and more recent releases and older releases, some of the app settings I don't believe were necessarily all under an apps folder. Some of them were more called out, but now you go to apps, you add a CalDAV account, because this is for calendaring, add the server username and password, and again, if it fails, you go to the advanced settings and set that magic URL that seems to make everything happy. Contacts is really the same sort of steps. The main difference is this one. You're going to add a CardDAV device because contacts use CardDAV and calendar uses CalDAV. You're going to do all of that, same sort of thing, advanced settings, it's the same set of steps. I do this here because I assume some people may want to come back to these slides after the talk if they want to set this up, and you just follow step by step. All right, so in addition, and this is true for macOS too, you want to install the app. In iOS, it has a native app, and here's what part of it looks like. The official App Store has it. Recommend installing it from there, of course. Once you do, you run and you launch it, you'll launch this account wizard. And what it will do is it'll load from the native browser, it will load into your Nextcloud instance and ask you to authorize this connection using your actual Nextcloud login on Safari on your iPhone. Once you do that, you can access all of your files remotely from the Files app. Once you install the app, you can what you'll notice if you launch Files, you'll see a little Nextcloud bookmark kind of in the sidebar, and you can click on that and access all of your files, and it will download and everything. You can also, because you have the app, you can go into the app and set what folders you want to sync, which is pretty useful, especially for a phone. You might want to sync, say, photos or maybe some documents or things like that. You can select which ones. And again, because phones typically have less storage than computers, you probably don't want to select everything if you have a lot of things in your files. I do recommend the initial sync from unmetered Wi-Fi, especially if you have a lot of files. But it's your internet. You can do whatever you want. I'm not your real dad. So also, what I recommend to do is go to settings, and then in the settings, there's a setting for auto upload that allows you to auto sync your photos, which is really handy. This is similar to like an iCloud feature that's really nice on iOS, which is you take a picture and all your photos now are backed up somewhere, right? That's really nice. Nextcloud has that option too. You toggle this on, and then you take a photo, and sure enough, in a little bit, it's in your files once it uploads, and then it's everywhere else. So now let's talk a little bit about some personal anecdotes about how what this looks like in practice. So we'll start by saying, like, this is really great to have your own cloud. It opens up a lot of capabilities for you that you wouldn't realize you'd be able to do that's under your own control. It has a lot of the advantages of iCloud without the lock-in. And really, that's like the big, that's sort of like the big disadvantage with iCloud is that it works great within the Apple ecosystem to sync all these things. But if you want to do anything outside of that ecosystem, it doesn't support anything outside of that ecosystem, right? So I found that Nextcloud is particularly powerful when you're using multiple OSs. And my family has a lot of different use cases, and let's get into them. So for example, my wife is a professional writer for both fiction and nonfiction. And so we mutually share our calendars. This is the thing that kind of got us into this. We both are using Google Calendars to just keep track of each other's schedules. My son's school also provides a calendar via an iCal link that you can add to your shared calendars, and you can see all the school events, which is very handy. And so we've done that as well. So it's very easy for us to coordinate our schedules and our son's school schedules and all this stuff using this. She also, as a writer, sometimes she'll write articles, especially nonfiction articles, where she's on location taking photos, and some of these artifacts end up getting pretty large. She might take many, many photos, and so there's a certain, if you have like one photo in a doc you're sharing, then fine, you might email it to an editor. But at a certain point, you reach that file size limit where people don't want you to email, and Nextcloud's been great for that. So she'll just to the editor, and then the editor can click on that and see all the files. It's been very convenient, then they can download them and it's no problem. It's sort of like the same sort of thing you would use with any other sort of commercial service, right? Like Dropbox or anything else, but you control the files and it's on your own device. So, and then finally, what she does is she uses calendars and the calendars and contacts are synced between her desktop and her iPhone. So they're all showing up on whatever app she wants to use for each of those. They show up. Easy to follow. All right. And there's my mother-in-law. So my mother-in-law is an accomplished artist. She mostly works in oils. She's actually used Linux for the past 20 years on the desktop. I set her up. So I set her up about 20 years ago when I first married my wife. And they actually preferred it to Windows, and it's not like, yeah, Kyle's coming in all the time doing maintenance tests. No, I just sort of threw Ubuntu on a computer, and they just mostly use web browsers, and they use GIMP and things like that. And they prefer it, they like it. So she's been using it for the last 20 years, no problem. It's been very little maintenance on my part. Every now and then they're like, yeah, we've had this computer for 6 or 7 years. Could we get a new one? Like, okay, let's just get a new one, transfer all the files to a new hard drive, and then you're off and running. Because it's Linux, you can just sort of typically boot it right back up. That said, so she has a really large wooden easel, right? And she puts her canvas on there, and then what she's been doing, she often will use a reference photo when she's doing an oil painting. And what she's done in the past is printed it out. And of course, if you're going to print it out for a reference photo, you want it to be really high quality, really good color. You want the colors to be correct. And that means you're using your best print settings, which means you're going through a lot of ink. And she does this a lot, so she's really going through a lot of ink. And just pretty much wasn't sustainable. And it's also a hassle. But beyond the ink cost, it's just a hassle to be like, okay, now I want to paint this. I have to go and print it out and make sure that it worked out and then tape it to my easel, et cetera. So we had this idea, what if we got her an iPad that she could mount to her easel, because they have nice screens. The color, in particular, what matters is the quality of the color on the screen, because she's painting from this as a reference photo. So the colors need to match the actual photo as much as possible. So got an iPad to mount to the easel. I then installed Nextcloud on the desktop and on her iPad. And then I set it up I pointed to her photos directory on her desktop, which is what she would normally have. She'd go to her photos, I want to print that one. Instead, that's synced to the iPad, and now she's very easily go to her iPad and go through and find the photo that she wants to paint, and then tap on it, and then it's full screen, and she can even zoom in, if she wants a little bit more detail from the photo to paint, and it's been working really great. All right, how about me, my cross-platform life? So I've been using Linux for about 25 years. At this point, I'm basically on the desktop as well, like primarily using, it's been my primary desktop for this entire time. That said, so for about 5.5 years, I worked at a company called Purism, where I was chief security officer and then president of the company, and we created hardware that ran all free software. I was a big, free software advocate for the company and promoting the value of having free software everywhere. Financial stuff happened, and basically I got laid off because couldn't really, anyway. It was a weird time, let's just say that. After that, because it's like a lot of soul searching, what does it all mean? I've devoted my life to the community and all this stuff. And I think there's probably people around here that you'll see that have been involved in some major free software project, open source company or things like that then had some level of massive burnout. And you'll see them react based on that burnout in some way for some time. Same thing happened to me. And so then, what does it all mean? I've been sacrificing for all this. It's a long story. We can talk about it more over beers later. This is not a therapy session. All that to say, I feel like I need to do appropriate setup to then say, so what I did at that point is I'm going to go all the other way. It's like such a bad breakup. I'm just going to, So I actually said, well, I'm going to try out the Apple ecosystem. I know a lot of people, probably in this room and definitely at SCaLE, perfectly happy doing all their open source development and everything else on a Mac. I'd never used a Mac before, so I'm like, I should try this out and actually know what I'm dealing with and try it out like a traveler in a foreign land. I'm not going to go into it and try to turn it into Linux. I'm like, let's try to use it like the natives do, and let me use all the native apps and let me speak the local language and all of that stuff. I'm not going to try to put a tiling window manager on my Mac or whatever. Let's just try to use it normally. So that's what I did. Of course, the big challenge with the Apple ecosystem is lock-in, right? It works really well with all of it makes it a very nice experience if you have all Apple devices. If you're trying to do a cross-platform thing, you have mixed results, right? It's kind of baked in to make that difficult. If you're using the native apps, which I was for the most part, I use Firefox, but it favors Apple hardware and services, and if you fall outside of the ecosystem, it's definitely not automatically working, and it maybe requires some work if it works at all. In particular, and you'll see a lot of people sort of complain about this, is that sometimes it can be challenging to get files and other things on and off certain devices, especially if you're trying to do that outside of the ecosystem. Now, if you have like an iPhone and a Mac, you can use iCloud and the files will sync back and forth in the settings, and it's all great. But if you have like an Android device in the Mac, maybe you have to add something special or try to getting the files on and off can be challenging. iCloud is convenient. Again, it syncs files and settings between your apps. It's really great, but it only works for Apple devices. So Nextcloud to the rescue. So to move to the Mac, actually, the funny thing is having Nextcloud already set up on Linux desktop made moving to the Mac way easier. Because all the files were there, so I set up Nextcloud like I just talked about. All my documents, all my photos, all my important files were just automatically on the device. It was just like they were automatically on all my other devices. I even synced a copy of my Firefox profile, which I then just sort of embedded into where it's stored on the Mac, and then my Firefox stuff was all up and running, and it worked fine. And that meant I didn't have to use Firefox Cloud, because everyone wants you to use their cloud, right, for syncing. It's like, yeah, I don't want to sign up for yet another account for that. I have my own cloud, so I can avoid theirs. The Nextcloud app put Nextcloud in the Finder, so I can just open up the Finder and see all my files there and access them. And what I also did was I changed the Finder bookmarks so that my pictures and docs replaced the local equivalents. So then when I just clicked on documents, I'm actually in my Nextcloud documents, a locally cached version. I can make a change, open a document, and then it gets synced everywhere. Same with pictures. Calendars and contacts shows up in native apps, which is great. I could just, again, live this native experience from this land that I never visited before, and everything just kind of worked with Nextcloud seamlessly. And then I used News as a newsreader across devices, so I didn't have to I wasn't using some sort of weird proprietary thing. I just opened up the web browser, load news, reading news, no problem. Same thing with an iPhone. Because the other thing about Purism was I was daily driving a Legion 5 phone, which is a phone that runs actual desktop Linux on it, and as part of my whole burnout coping mechanism, I'm like putting all this aside and like, well, what does that leave me with? Well, I guess I could do Google, but I just talked about how I was de-Googlefying my life for the longest time. Like, do I really want to go back to that ecosystem? Not so much, and you're saying, but Kyle, what you could do, did you know that you could take an Android device and then you can install Linux on it, and then you'd have actual Linux, or you can install these other tools that, it's like, I'm trying to think of it, I was taking a vacation from that for right now. I needed some time to myself, take a vacation from all of that fiddly stuff, because like, basically I had developed very thick calluses from years of using Linux tools, all the rough edges, I didn't feel a thing, right? Something about this experience basically ripped all of those calluses off, and so I was very sensitive to all of these paper cuts. And so I needed some time to avoid paper cuts. Anyway, so I moved to an iPhone. Like I said, calendars and contacts sync is very seamless. I installed the native app and synced a subset of files, so my photos and all that stuff that I wanted to be on there synced, and it's very convenient. And again, all the photos taken on the phone syncs up to Nextcloud, so I can immediately access it on a desktop. I can immediately access it on other devices. It's great. And again, the News app actually it works well in the mobile browser. You can just scroll through it. It does what you think a modern web app should do on a mobile browser. It behaves appropriately. Now, importantly, it also made it easy to move away from a Mac because it's not hard to get inside the garden, right? Sometimes it can be hard to leave the garden. And so I did miss Linux on the desktop. It took, I needed to take a vacation. I took my sabbatical, worked through some things, and then I got to a point where I'm looking around like, I kind of miss this, and actually I want to get back and daily drive this. I mean, I had been keeping up with Bluefin on an old ThinkPad. Like I said, you can get those on eBay for under $50 almost always. So this one wasn't. I traded with a friend. But anyway, I had an old ThinkPad. I was like keeping up with Bluefin and trying this stuff. I was like, you know what? I think I'm ready. I think the time is right. I think I'm ready to immigrate back home. So I did. I ended up using Nextcloud. And the great thing about Nextcloud is it made it, even before I had switched to what my daily driver is now, just having Bluefin on this old ThinkPad, Nextcloud made it easy to just today I'm going to see what Bluefin's like. I'm going to put the Mac aside and just put this on my lap and try it. And all the files were there. Everything was just synced. The calendar was there. All the things, it was pretty seamless to just pick up one device or the other than all the key bindings being different, right? So that was a nightmare, but that's okay. Just like switching from a ThinkPad to something else, the function and control keys are always like different. So you go to like a regular keyboard, it just drives you crazy. You get used to it, it's fine. So I actually chose a Framework 13 as my daily driver. That's what I'm presenting on, and it's fantastic. I couldn't give higher praise for it. I really enjoy it so far. And to test Nextcloud, actually, because I knew I was giving this talk, I did a fresh install. So I didn't just like take a hard drive from something else or just like copy home directories over or whatever. I wanted to see what it would be like, and basically just did a fresh install on this, everything blank, and then installed Nextcloud, and stuff started happening, right? Like stuff started syncing over. I used the file sync to copy over my Mac profile, Firefox profile, which at this point had been updated and changed, right? So I found that folder and put it back in the Nextcloud, and then it was right there for this to copy over the local version of the profile. Calendars, contacts, files just work as you might expect. And then I did things like I updated the home directory, so I sym-linked the docs pictures directories to the Nextcloud folder, so then when I'm opening files, the Files app, I can click and it goes right to Nextcloud, like you would expect. What I'm considering now is expanding this kind of sync. A lot of people have way more sophisticated setups for this sort of thing than I do, where they may have multiple Linux desktop devices and all their like dot files and stuff automatically sync between things. I'm considering some of that. I just haven't exactly decided which things I want to do yet. I'm experimenting here and there, so maybe more to come on that. But yeah, so that's another option that I want to look into later. So, conclusion to all of this. Groupware and file sync clouds are very useful. But the problem is some of them reinforce lock-in. Once you kind of get in, you can get in pretty easily, but it's kind of hard to get out. Nextcloud provides all the major features of many of those providers and some features that they don't provide. And it can be self-hosted, which is great. It works across platforms, so it makes switching between them easier, even switching between them the same day easier. And in general, I would say it's a great alternative to iCloud. Like specifically, it's a great alternative to iCloud, but it's also a great alternative to a lot of other groupware solutions. And I think I would recommend it in particular for family groupware. It doesn't require a lot of resources if you just want your family to have some sort of shared thing. It doesn't take a lot, like I said, modern Raspberry Pi, no problem. It should be no problem. So yeah, thank you very much. It's time for Q&A. I really appreciate everyone coming out. Last talk of the day, of the last day. I appreciate your dedication. And yeah, thank you very much. I appreciate it. All right, yeah, question.
One of the nice things about iCloud is the backup, being able to do a backup of a phone or I guess a Mac. I haven't done it for a while. Is it possible to do a time machine backup from the Mac? Is it possible to do a time machine backup from the Mac or from an iPhone to Nextcloud? I think maybe especially the iPhone, or do you find that the normal home directory syncing is enough and you don't really need to do backups?
Yeah, oh yeah, we have the mic so I don't have to repeat it. Great. So I didn't try Time Machine with a Nextcloud folder. I know that Time Machine can be somewhat particular even when you're plugging in an external disk. It needs to be formatted certain ways. So Bill knows. So yeah, so the answer for the crowd was that you can have an SMB mount, although I've heard recently that you have to go in and change a particular protection setting because of SMB. There's issues with the SMB integrity sometimes over the network, so Time Machine can be a little finicky about it. So it's an option, but again, I think what your thing is you like the sync, maybe you have multiple Macs and it'd be kind of cool if it's synced across. So for things that were like Apple-centric, I didn't use Nextcloud, for example, to sync my Apple account type stuff because I figured, well, all those things are in that ecosystem, they can just be happy in their ecosystem. And then it's mostly like other files like Firefox profile and stuff. Thanks for the question. Yes?
How does credentials management work in this world? Did you have everybody create credentials on your home system and then have them enter them, like username, password on their devices, or what?
Yeah, so everyone basically username, password. Nextcloud does support, have plugins you can add to enable multi-factor authentication if you want to. For my family and our use case and our threat model, I didn't think it was necessary. So basically there's an account management in the UI, and if you're an administrator, which I am there, you can add new accounts, and I would just add accounts with their email, and then and set a password, and they can go change it once they log in the first time if they want to. And then, because I'm the one that's setting it up for my family generally, so what happens is I would set up, like for my mother-in-law, I created the account, then I would go to her home, install the Nextcloud app, and like set up the sync and stuff for her, and same with the iPad. But yeah, so it's pretty straightforward username, password. Any other questions? Yes.
What's your kind of recommended way, if you have experience with it, to share photos, like from an iPhone? So my buddy here has Nextcloud at home, and we took some photos at his birthday party, and like, for the life of me, I could not figure out how to upload those photos into his Nextcloud, except maybe one by one. But there was like no easy batch, or because I want to upload batch upload a bunch of photos and videos, let's say.
Yeah, so yeah, if you had an Nextcloud account, and you installed the app, then you can set it to auto-sync new photos, right? But that doesn't help. So first step would be to do that. It would auto-sync your new photos. For your old photo, if you want all of your photos,
Right, not all, just like one album, right?
one album, then basically what you can do is you can set up a sync a folder, like go to the files part of the Nextcloud app, and have a folder that is shared locally, and then you can drag those photos there. So if your Nextcloud account, if you go to files and just create a photos directory, I think they automatically now have like a photos directory in Nextcloud, maybe, but if not, create one. And then on your iPhone, you'll see in the Nextcloud sort of bookmark on the side of the files app, you'll see when you click on it, like, oh, there's photos, okay. Then you can go to your pictures and select the ones select the album, and then copy it. You just copy and paste, right? You can go back to that Nextcloud photos and say paste, and then it'll sync it.
Oh, so you do it in the Nextcloud app for iOS, basically?
Yeah.
As opposed to like in the web interface?
Yeah, not the web interface. I would recommend going into the app, and then it'll just sync.
Cool, awesome, thanks.
Yeah, no problem. Any other questions? Yes.
These are comments, I'll admit, rather than questions, but they're helpful. Because I'm a Nextcloud fanboy like you. If you run an organization and it's beneficial to have your logo on your Nextcloud, that's a feature built in. So you basically get to white label it. I use mine with customer-facing support and work with my clients. And they are very impressed when they log in and they see my stuff. They know they're where they're supposed to be. That's a helpful feature. The other thing is, for those of you who enjoy development, the Nextcloud project has been building out rich developer resources to get you started easily making your own apps for anything that isn't in the large collection already in the App Store.
Any other questions?
Any questions?
Well, awesome. Well, thank you. And anyone who was too shy to do it in front of everybody, you can come talk to me after. I'll be around. So yeah, thanks everybody again.
Thank you so much, Kyle. Thank everybody for coming out to SCaLE.